Welcome to our guide on controlling Varroa mites in honeybee colonies using chemical treatments. These tiny parasites pose a significant threat to our vital pollinators. In this video, we will explore effective chemical treatments to protect these industrious creatures. Proper planning, accurate application, and adherence to safety guidelines are crucial. Let's delve into the details of these treatments, understanding their mechanisms and learning how to apply them responsibly. Our goal is to equip you, the beekeepers, with the knowledge and tools to combat these tenacious mites and ensure the well-being of your hives. Our first line of defense is formic acid, a naturally occurring compound found in the venom of ants and the stings of nettles. Formic acid works by disrupting the mite's ability to reproduce and feed on the developing bee brood. Imagine a cloud of vapor released within the hive, penetrating the crevices where the mites seek refuge. This vapor, while harmless to the bees at the correct concentration, spells trouble for the Varroa. One popular method of application utilizes formic acid pads. These pads, impregnated with the acid, are placed on top of the brood area inside the hive, where they slowly release their vapor over a period of 7 to 10 days. Timing is crucial, as formic acid is most effective when daytime temperatures are between 50 degrees Fahrenheit, 10 degrees Celsius, and 85 degrees Fahrenheit, 29 degrees Celsius. However, we must remember that formic acid is corrosive. Therefore, protective gear, including gloves and eye protection, is essential when handling this treatment. By harnessing the power of this natural compound while taking the necessary precautions, we can deliver a targeted strike against the Varroa infestation, giving our bees a fighting chance. Our next weapon in the fight against Varroa is oxalic acid, a naturally occurring substance found in many plants, including rhubarb and spinach. Oxalic acid, when used correctly, can deliver a precise strike against the Varroa mite. Unlike formic acid, which works through vaporization, oxalic acid is most effective when it comes into direct contact with the mites. This is where timing becomes crucial. Oxalic acid treatments are best applied during periods when there is no brood present in the hive, typically during the cooler months. Two primary methods are employed in applying oxalic acid: vaporization and trickling. The vaporization method involves heating oxalic acid crystals using a specialized vaporizer. This creates a dense fog that permeates the hive, coating the bees and the mites alike. The trickle method involves applying a sugar syrup solution containing oxalic acid directly onto the bees within the hive. Regardless of the method chosen, it is essential to apply oxalic acid when daytime temperatures are between 40 degrees Fahrenheit, 4 degrees Celsius, and 50 degrees Fahrenheit, 10 degrees Celsius. By understanding the nuances of oxalic acid and employing it judiciously, we can target the Varroa mites without harming the bees or ourselves. In our arsenal against the Varroa mite, amitraz stands as a powerful synthetic miticide. Amitraz works by affecting the nervous system of the Varroa mites. It disrupts their ability to function, ultimately leading to their demise. One common method of application involves using amitraz impregnated strips, which are hung within the hive, typically in the brood chamber where the mites are most active. These strips release amitraz slowly over a period of about 42 days, providing continuous control. Timing is less critical with amitraz compared to formic acid or oxalic acid, as it can be used effectively within a broader temperature range. However, a note of caution is warranted. Overuse of amitraz can lead to the development of resistance in the mite population, rendering the treatment less effective over time. Therefore, it is crucial to use amitraz judiciously, rotating it with other treatments to prevent resistance. By employing amitraz strategically and responsibly, we can add another layer of protection to our hives, helping to ensure the long-term health and productivity of our bees. As we've seen, the fight against the Varroa mite requires vigilance, knowledge, and a willingness to adapt. By understanding the strengths and limitations of each chemical treatment and by adhering to safety guidelines, we can effectively control these tenacious parasites and safeguard the health of our honeybee colonies. Let us continue to learn, to share our knowledge, and to work together to ensure that bees continue to thrive for generations to come. By following these guidelines and using the right chemical treatments, you can effectively control Varroa mites and ensure the health of your honeybee colonies. Happy beekeeping!